The AIF-C01 exam heavily tests AI/ML fundamentals, and the easiest way to blow it is thinking they're the same thing. This video kills that confusion. AI is the big umbrella, any system doing human-like tasks. Machine learning means it learns from data, not hard-coded rules. Deep learning uses multi-layered neural networks for things like image recognition in Amazon Recognition. A rule-based chess engine is AI, but it never learned from data, so it's not ML, and definitely not DL. Traditional programming. You write explicit if-then rules. Machine learning flips that. You feed in labeled data, and the algorithm finds the patterns. Take a spam filter. Instead of coding, if it has the word free, mark spam. You give it thousands of emails labeled spam or ham, and it figures out the rules itself. Try it in Amazon SageMaker Studio. You can build your first ML model with no upfront infrastructure. Deep learning uses artificial neural networks. Input layer, hidden layers, output layer. Each hidden layer automatically extracts higher-level features, edges, shapes, then whole objects. AWS SageMaker. Jumpstart gives you pre-trained deep learning models you can fine-tune in minutes, no PhD required. Supervised means you have an answer key, input, and the correct output. The algorithm learns the mapping, like a kid with flashcards. The term supervised does not mean a human watches training. It means the data is labeled. Amazon SageMaker. Ground truth can create those labels for you, turning raw data into supervised gold. Supervised learning splits into two jobs. Regression gives you a number, think home prices. Classification picks a bucket, spam or not. On the exam, know which one answers how much versus which class. Amazon SageMaker Linear Learner handles regression out of the box, and XGBoost is the Swiss Army knife for both. Linear regression fits a straight line through your data points to minimize the difference between predicted and actual values. The rookie mistake? Using it on data that curves unless you do feature engineering first. Amazon SageMaker. Linear Learner does the heavy math, but you still need to check your residuals. Logistic regression does classification, not regression, despite the name. It squashes the output through a sigmoid curve into a probability, 0.2 for not spam, 0.9 for spam. If you pipe a binary outcome into plain linear regression, you'll get predictions like 0.3 or 1.5, which makes zero sense. SageMaker's built-in logistic regression prevents that blunder. Decision trees ask a series of if-then questions. Easy to explain, but one deep tree overfits faster than a cheap suit. SageMaker XGBoost builds an ensemble of trees that vote together, giving you both accuracy and a feature importance chart for that stakeholder meeting. An SVM finds the boundary that maximizes the gap between classes, the margin. When your data isn't linearly separable, the kernel trick projects it into a higher dimension where a flat wall suddenly works. SVMs aren't a built-in algorithm in SageMaker, but you can use them via custom containers or bring your own script. That said, for most tabular tasks, XGBoost has stolen the spotlight. But what if you don't have labeled data? That's where unsupervised learning shines. It finds hidden patterns in raw, unlabeled data. Real-world example: customer segmentation. A common mistake is assuming unsupervised means zero human input. You still choose the algorithm and must interpret the clusters. Amazon SageMaker's built-in k-means lets you group customers without ever tagging a single row. K-means iteratively assigns points to the nearest centroid, recomputes group centers, and repeats until stable. The tricky part? Choosing k, use the elbow method. Run k-means for k, order 2, 3, 4, and plot inertia versus k. The bend is your sweet spot. Now spin up a SageMaker notebook, load your customer data, and call the built-in k-means algorithm with multiple k values to see how segmentation changes. Principal component analysis projects: high-dimensional data onto fewer dimensions, preserving variance. Think of flattening a 3D globe onto a 2D map. You lose detail but gain overview. SageMaker offers a built-in PCA algorithm for noise reduction and faster training. Semi-supervised learning stretches a small labeled dataset across unlabeled data, a massive cost saver. AWS Ground. Truth bootstraps labels by having an initial model suggest annotations, which humans verify, significantly reducing labeling costs compared to full manual annotation. Reinforcement learning. Agent acts, environment responds with state and reward. Agent updates its policy to maximize rewards. Picture a robot learning to walk. Punishment for falling, reward for standing. It refines on its own. AWS Deep Racer lets you train an autonomous race car in a virtual simulator, tweak a reward function, then race on a physical track. It cements RL concepts. Step this week. Take the free AWS Deep Racer student course to build and race your first model. Sweet spot. A model that generalizes. Underfitting leaves value on the table. Overfitting crumbles in production. Catch it early by watching the gap between training and validation curves in SageMaker. Plot model complexity against total error, and you'll see a U-shape. Left side, high bias, underfitting. Model can't capture the trend. Right side, high variance, overfitting. Model swings wildly with small data changes. The optimal complexity minimizes the sum of bias and variance. Exam tip. If a question says a model has excellent training accuracy but poor test accuracy, it's screaming high variance or overfitting. Accuracy is dangerously misleading with imbalanced datasets. A model that blindly predicts the majority class can hit 99% accuracy while totally failing on the minority class that actually matters. The antidote is a tool you'll meet next, the confusion matrix, which shows exactly where your model is getting it right and wrong. Sketch this 202 on scratch paper. True positive, false negative, true negative. From these four numbers, every classification metric is born. SageMaker evaluation reports automatically generate this matrix, so you can focus on interpreting what it tells you about your model. Precision and recall pull in opposite directions. A spam filter tuned for sky-high precision might let real spam through. Poor recall. Choose your metric based on what hurts more, a false positive or a false negative. The exam will ask you to articulate this trade-off. F1 is the harmonic mean, ranging from 0 to 1. It balances precision and recall when you need a single metric. SageMaker evaluation reports include F1 automatically. But don't assume it's always the right answer. When the cost of false negatives is extreme, pure recall matters more. Row C curve plots. True positive rate versus false. Positive rate at various thresholds. The area under the curve, AUC, ranges from 0.5, random guessing, to 1.0, perfect separation. Higher AUC is better. SageMaker training jobs provide AUC right out of the box, and the exam expects you to interpret it. Memorize this sequence for the exam. Collection, pre-processing, feature engineering, training, evaluation, deployment, monitoring. In reality, most of your time will be spent on the first three stages. SageMaker supports every stage, from data wrangler to model monitor. Your model is only as good as the data it's built on. Common AWS sources include S3 buckets, Kinesis streams, and the AWS Data Exchange for third-party datasets. Before you train anything, use AWS Glue to catalog and discover what you actually have. Otherwise, garbage in guarantees garbage out. Cleaning consumes the bulk of the ML lifecycle. Skip it, and you risk data leakage or biased predictions. AWS Glue. DataBrew gives you a drag-and-drop interface to profile and clean data without writing ETL jobs, essential for AI practitioner candidates who need to know the right tool for the job. Feature engineering extracts signals from raw data, splitting date parts, one-hot encoding categories, TF-IDF for text. SageMaker. Data Wrangler streamlines these transformations, a critical step for algorithms like SVM or KNN. Always scale numeric features to a 0-1 range, or distance-based models will be thrown off. Evaluating on the same data you trained on is like letting a student grade their own exam. SageMaker automatically splits your dataset when you configure the split ratio. Use 60-20-20 and always set a random seed for reproducibility. The exam expects you to know this prevents overfitting. Training iteratively adjusts weights to minimize loss using gradient descent. The learning rate controls step size. Too high and you overshoot the minimum, too low and you crawl. SageMaker handles distributed training automatically, but you need to understand the concept for questions about convergence. Hyperparameters are knobs you tune before training. Learning rate, tree depth, cluster count, regularization. They're not learned, they're set. Mistaking them for parameters is an easy trap. SageMaker. Hyperparameter. Tuning uses Bayesian optimization to find the best settings automatically. Responsible evaluation means never trusting a single number. Use cross-validation, examine confusion matrices per class, and enable SageMaker Clarify to catch bias. Training accuracy alone is a dangerous trap. Add Clarify to your training job and sleep better. Deploy your model as a SageMaker endpoint for real-time calls, or use Batch Transform for bulk predictions. Always version your models in SageMaker Model Registry. Jump into SageMaker Studio and hit the one-click deploy button to see it live. MLOps is the CI/CD of machine learning, a radial cycle from data to train to deploy to monitor, then retrain when drift hits. AWS uses SageMaker pipelines, step functions, and EventBridge to automate this. Without it, models degrade silently. Model accuracy looks great on day one, but data drift can pull it down over time. SageMaker. Model Monitor detects both feature drift and prediction drift. For the exam, no concept drift, what we're predicting changes, versus data drift, the input distribution shifts. Domain 1 exam question. Group customers without labels. Right away, rule out supervised, needs labels, and reinforcement, rewards. The only logical answer is unsupervised clustering. Use elimination strategy religiously on the exam. 2 classic pitfalls. Thinking unsupervised learning requires a human to verify clusters. It doesn't, it's automatic. And saying reinforcement uses labeled data, it learns from trial and reward. Fix these now, or the exam will catch you. SageMaker's built-in menu has 15+ algorithms. Linear Learner handles regression, XGBoost rules tabular data, image classification uses CNNs, and blazing text tackles text. Picking the right one saves weeks of custom coding. Know their primary use case for the exam. On the AIF-C01, don't assume all neural nets are CNNs. CNNs excel at images, think recognition, while RNNs handle sequences, transcribe. Grasp the distinction, CNNs for spatial, RNNs for temporal. No math, just recognition. Transfer learning lets you take a pre-trained model like ResNet, fine-tune it on your own small dataset, and get state-of-the-art results fast. SageMaker Jumpstart gives you hundreds of pre-trained models. Try one in the free tier this week. No GPU cluster needed. Feed an all-male hiring dataset to a model, and it learns to discriminate. The exam tests responsible AI. No selection bias and confirmation bias, cold. Use SageMaker. Clarify to run bias analyses, pre-training metrics, post-training checks, and feature importance reports. Flag issues before you deploy. SHAP and LIME are 2 techniques that explain model predictions. SHAP uses game theory to assign each feature a contribution value. LIME perturbs inputs around a prediction. In regulated industries like healthcare and finance, this isn't optional. HIPAA and GDPR demand transparency. SageMaker. Clarify generates feature importance reports right inside your pipeline. The exam loves the acronyms SHAP and LIME, so commit them to memory. To master Domain 1, start with the free ML Basics course on AWS Skill Builder. It maps directly to exam objectives. Then read the Machine Learning on AWS white paper and test your knowledge with tutorials, dojo practice exams, and the official sample questions. Block out 10 hours this week. That's all it takes to lock in these fundamentals. You can run this entire lab in one sitting using the AWS free tier. By actually training a linear learner model, you'll cement concepts like input features, target variables, and prediction endpoints. The exam won't ask you to write code, but having hands-on experience makes algorithmic questions far easier to reason through. Create 20 digital flashcards in Anki. It's free and uses spaced repetition to push terms into long-term memory. Include every definition from the official exam guide: AI, ML, DL, supervised, unsupervised, reinforcement learning, and all evaluation metrics. 5 minutes of daily review on your phone will make these concepts reflex level by exam day. The biggest mistake candidates make is cramming unfamiliar topics the night before. Instead, reinforce your weak spots with this checklist. Reread the metric definitions, redraw the life cycle, and solve one confusion matrix. Then put the books away. Your brain needs sleep to transfer what you've learned into long-term memory. Many AIF-C01 questions ask you to pick two answers. Use elimination. First, discard the obviously wrong options. Here, that deep learning is synonymous with AI, needs small data, or is only for images. Then you're left with two clearly correct statements. Practice this pattern on Tutorials Dojo's review mode. You'll see a dramatic speed improvement on the real exam. Domain 1 isn't just academic. It's the decision-making engine for your AI work. When a stakeholder asks whether to build a custom model or use a pre-trained service, you'll know to reach for SageMaker or Recognition based on data availability, accuracy needs, and cost. This foundation underpins every other domain in the exam, and it's what separates a memorizer from a practitioner. Part 3 will cover generative models. They create new data, unlike the discriminative classifiers you just learned. Generative models often use unsupervised learning. Understanding that distinction ties directly back to Domain 1 fundamentals. Hit subscribe. Part 3 drops Thursday, and it's a dense topic you don't want to miss. 5 AWS AI services pop up on the exam. Comprehend handles NLP tasks like sentiment. Recognition analyzes images and video. SageMaker is the build, train, deploy platform. Lex powers chatbots, and Poly turns text into lifelike speech. Memorize these names and their basic function. They're free marks. The ML lifecycle order can trip you up. Use this silly mnemonic. Crazy people eat tacos. Everyday morning. That stands for collect data, pre-process, engineer features, train the model, evaluate, deploy, then monitor. Practice reciting it forward and backward to answer the inevitable ordering question. Exam writers love to flip definitions. Train your eye to spot traps like supervised learning uses unlabeled data. That's a distractor. The correct version is labeled data. Recognize the reversal and you'll avoid easy mistakes. Metrics can mislead. Avoid accuracy on imbalanced datasets. Remember that AUC doesn't give you the threshold. Always report both precision and recall and map errors to real business impact. Choose the right metric for the problem. Don't waste precious study hours on GANs, transformers, or advanced reinforcement learning. They aren't in the scope for AI Practitioner Domain 1. Instead, drill linear regression, decision trees, SVMs, and k-means. Those are the algorithms that show up. Here's your 7-day plan to lock in Domain 1. Each day, commit 1.5 hours. By day 7, you'll know the definitions, algorithms, metrics, and lifecycle cold. Check off each day as you go. Use spaced repetition to defeat the forgetting curve. Load the 20 flashcards from Scene 45 into Anki. Schedule reviews at 1, 3, and 7 days. This simple method can double your long-term retention. Don't just reread, actively recall. Failing isn't the end. If you don't pass, examine the score report. Reinforce the weak areas with these videos and retake after 14 days. Check the current exam fee on AWS's site. Plenty of professionals pass on try too. It's part of the process. This exam is your launchpad. After AI Practitioner, Aim for the AWS ML specialty. More hands-on, but Domain 1 knowledge fully carries over. Then you can go for professional level certs. The path is clear. Stop consuming and start doing. Open AWS Skill Builder, finish the free 1-hour ML Basics course, then launch SageMaker Studio and build a linear regression model with the Boston Housing dataset. Set a 25-minute Pomodoro timer right after this video.